All right, let's look at a couple more possible bond formations. Now, remember when we talked about the periodic table and we talked about how you can predict ionic behavior based upon the periodic table? If we look at the periodic table and we saw that hydrogen here only forms a single bond, just like we saw with lithium, sodium, potassium, and rubidium, these form ionic bonds. These generally do not form covalent bonds. These are ionic, but they lose one electron. Now, in comparison to that, hydrogen forms a single bond because it just needs one more electron for a full shell. All right, so you can see how these kind of behave similarly. So hydrogen is one of a few special cases when it comes to covalent bonds. But remember that in general, when we're talking about ionic bonds or covalent bonds, we have this rule that we call the octet rule, okay? Which means that you want to satisfy a complete octet in that outermost valence shell. With that in mind, then, coming across here, carbon, we can see, if you remember, its electron configuration for carbon. So the electron configuration for carbon would be shorthand. Helium would be our 1s2. Then you have 2s2, 2p2, which gives us a total of 4 valence electrons. And since it's got 4 valence electrons, it wants to complete that outermost electron shell by sharing 4 more electrons. Okay, so in general, carbon and the atoms beneath it, carbon and silicon right here, these two right here, based on where they are in the periodic table, generally wish to share 4 more electrons. Now, if you look then at this pattern, we've got the electron configuration for nitrogen. It is also still helium, but you add another electron, so 2s2, 2p3, giving us now 5 valence electrons, meaning that for nitrogen and the ones beneath it, in its group here, these, when they form a covalent bond, wish to share 3 electrons. And you can see as this continues along, then oxygen, sulfur, selenium in that group here with oxygen, we would generally say that the trend would be sharing 2 electrons, and the halogens with fluorine at the top there, here, they want to just share a single electron, so sharing 1 electron. That's the general trend of the periodic table, okay? Let's stop here, we'll move on to the next lecture.